Welcome to the Dental Equipment Repair Channel. This is Jason. I wanted to take some time today to go ahead and share with you one of my favorite places on Facebook. This is an incredible page here with nothing but dental equipment service technicians. These are my people. These are all dental technicians from all over the world. Most are located in the United States, but there are a few that are in other countries as well. And this group is the Dental Equipment Repair Service Technicians Group. And there's you can see there's just over about 200 members. And this is a tremendous group for anybody that is working on dental equipment or wanting to become more knowledgeable about working on dental equipment. This group has been great for, I would say there's probably two reasons that I really appreciate this, at least two reasons that I appreciate this group. One of them is that I get an opportunity to see unique problems and issues that are happening in other technicians' territories. And I get an opportunity to witness technicians talking about specific problems. This helps sharpen me as a technician and makes me aware of unique problems as well as how to solve them. The other great thing is when I'm stumped myself, I can actually post a question very quickly. And this group is incredible because all of my friends race each other to provide just a multitude of answers. And just like anything, you get some right answers, some wrong answers. You get answers that lead to other questions that help you more fully consider an issue. And this group is just, I can't say enough about it. And because I decided to make the Dental Equipment Repair channel, this group is extremely relevant to the type of things that I'm trying to train and trying to get out there on the YouTube channel. Whenever I release a video, I always drop the video here. And in this video, I'd like to feature a issue that happened with one of my peers and to kind of walk you through it, because this is a problem that I think is worth learning a little bit more about. Now, a little bit more about the group. This group is basically for technicians only. This is not for doctors, and this is a basically opportunity to share information to help others or to get help yourself. So no matter what your stage in dental equipment repair is, if you're new, if you're really knowledgeable, everyone has a place here, and it's a very collaborative and a very generous environment. All the time, people are exchanging ideas and even providing each other with parts and unique resources that we can share amongst each other. And this is basically, these are the rules. You have to be a technician, and it's not for lab techs. And as you can see, it's a fairly active group with over 100 posts in a month, and it's been going for about 5 years. So today I'm going to show you a video, and we'll kind of talk about it, and I hope you enjoy it.
Running a handpiece at about 55 pounds of pressure. I hit the air water syringe air and hold it, and my pressure drops off. I let off to the button, and it comes back up. Hold it.
One of the key principles to this issue is a theory called Pascal's law. And this might seem a little bit kind of beyond what you need to know, but essentially I do want to identify and give some acknowledgement to this principle, because this is really the key to the issue we're seeing here. And this is a principle in fluid mechanics that states that a pressure change at any point in a confined, incompressible fluid is transmitted throughout the fluid such that the same occurs everywhere. So in other words, if you have they have like a little bit of a depiction here, but basically whatever the pressure is here, it's the same pressure as here, 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 everywhere inside. And so whenever we're working on dental units, we need to remember that inside the tubing, all the tubing that's connected, all the points in the system that are connected, that pressure is the same everywhere. So if it in the floor box, if it's 80 psi at the gauge, then that means it's 80 psi at the furthest point from that in the tubing that's connected to that. So again, this is called Pascal's law, and this is part of what we do, and understanding this principle will greatly assist in understanding this issue as well as any other issue about dental air. So to get things started off right, I'm going to show you where I found the manual for the Adec delivery unit that we're going to be studying. This is a website called Frank's Hospital Workshop, and this is a pretty incredible resource for anybody working on dental equipment as well as biomedical equipment. This website is actually run out of, I believe it's run out of Kenya, and this is, yep, it's run out of Mpawa, Kenya, by a gentleman, Frank, and this is a just a really neat grouping of resources for biomedical technicians. And what we're going to do with this website is we're going to go over here to equipment. And over here, these are all the different types of biomedical equipment that there are manuals for. And specifically, we're going to go ahead and look at the section called dental units. And then we're going to go to service manuals. And here we have all of the different manuals that are relevant for us here in dental industry. Now, as you can see, there's a lot, but for the unit that we're working on today, it is a Adec, and it is the Adec delivery. I'm sorry, Adec handpiece controls. So we'll go ahead and click there and there. Okay. Now, from here, this is actually the Adec manual, and this will find the basically some service information for a Cascade style delivery unit. And if we scroll down here, we've got just a bunch of information. Now, we are going to basically be down here to handpiece controls. Now, for the specific issue that we saw in the video, what's happening was the handpiece itself, which is signified by, let's see here, it's actually not reflected here. This is all of the incoming floor box utilities, and this is your air water syringe. Now, this particular drawing, we can see more clearly how the air water syringe is hooked to the control block here. And specifically, the issue that we're seeing is going to involve the syringe, and it's going to involve basically this switch number 5 here, which is a master on-off toggle. And we'll explain why here in a second. But for the purpose of just being able to kind of see how things are laid out, this is master air, which comes from the floor box to your master on-off switch, and then it basically goes back here through your control block and over here to the post box. And that's called pilot air and master air. All right? So now we're going to scroll down here. And this picture is a little bit larger depiction of what we're working with there. And kind of notice, as I said, it's a little bit harder now to see this, and everything is kind of a little bit tougher to see individually, but it'll be okay. So now, right here, the air filter and regulator assembly is where your air comes into the chair through this valve. And this is a toilet style valve called a angle stop. Usually you'll see them behind the toilet, and that's the one they use to control the water. In your floor box, you'll have two of these, one hooked to air and one hooked to water. Now, what's happening is with this particular valve, you have air that's sitting right here on this side of the valve. Now, we were talking about the master on-off switch. So what happens is this solid line right here, I don't know if you can see it, but it's the one that is kind of right, it's right there on the side of the housing, and that is basically filtered, unregulated air. And that is the air that is always present going through this hose. Okay, comes up here, follow it, we'll follow it to the master on-off switch. Okay, now when the switch is off, the air is blocked, and when it switch is turned on, the air actually comes over here through this block, and then the air will come backwards through this little striped one, this yellow and orange stripe, come back around through here, come back around through here, over here, and then it comes through an 80 psi regulator, and that regulator regulates it to the basically the diaphragm. And so essentially what's happening is this master on-off switch controls air going to this regulator. The regulator adjusts the pressure to 80 psi, and basically this valve will then allow 80 pounds of air to come through. Now, when that air comes through, we actually have it come through a couple different ways. It comes through this large hose, which ultimately feeds your handpieces. This is a 1/4 inch hose, and we have a smaller 1/8 inch line, okay, and then a gauge. So basically, these three yellow hoses are all at the same potential. Now, if we follow this yellow hose back, we're going to go back to the prior page that we were on. Basically, we have that regulated air, that 80 psi air, comes back here, and it comes into this block. Now, what you'll notice is coming out of the block is where the air-water syringe is fed. So basically, this yellow line is what typically provides air coming back to the syringe. So just to recap, we have that unregulated air coming through here to the switch, which goes back through here, and then it goes back to the pilot air. It goes through our two regulators, through specifically this 80 psi regulator, which opens everything up and then allows the air to come back through here to the regulated air, which is that it's regulated to 80 pounds, and then that feeds through. Now, the problem that we saw, I'll go ahead and repost the video here in this segment, just so you can be reminded.
Running a handpiece at about 55 pounds of pressure, I hit the air-water syringe air and hold it, and my pressure drops off. I let off of the button, and it comes back up. Hold it.
So now we're going to go ahead and dive into this problem, and we're going to talk about a little bit more about how the system works as well as why the problem happened. So the syringe air is pulling from the control block, and it's pulling specifically from this little yellow hose that is supplying that regulated air pressure for use for the patient. And usually what happens is the air is being pulled kind of from this point right here. And that's fine. In the situation of the video, what's happening is that at some point the unit was maintained or worked on by somebody, and the syringe was hooked into, instead of this little yellow line through the block, the syringe itself was hooked into either of the two lines for the master on off switch. Now, the reason this is a problem is because when you push that air water syringe button for the air, it's essentially like making a big leak on the system. Now, the system is able to keep up with the leak through this whole network of the regulator, basically the regulated air. It's designed to put out enough air. The issue is, though, it's the air water syringe is draining air pressure from the master on off switch. It basically reduces the pressure to this regulator, causing this pressure to decrease, and then in turn decreasing the amount of air coming off here to the handpiece. All right? So in the same way that the regulator, it regulates 80 psi to control the output at 80, if that drops anywhere below 80 psi right here, the actual regulator causes the unit itself to run at less pressure. So essentially, everything from this point forward on the system is the same pressure. So if this is 80, then this is 80. And if this drops down to 40, 30, 20, then this is 40, 30, 20. So essentially, what we saw with that problem is that the air water syringe was plumbed in somewhere that it shouldn't have been. It was plumbed here onto the master on off switch. And I've definitely seen this before. This is it's a tricky problem. And one of the reasons that this is such a tricky problem is because if you think about the operation, and this is what we have to do as technicians, is we have to think about how the equipment's being used. If the handpiece is being operated by itself, the problem will not occur. But as soon as you have an assistant, or as soon as you have the doctor picking up the air water syringe and operating the air syringe at the exact same time that they're operating the handpiece, that's when the problem will occur. So the syringe air has to be moving in order for the pressure to drop down, which would make this an extremely frustrating problem because it only happens during a unique set of circumstances. And we'll also go ahead and look over here, because this is the doctor's syringe and this is an assistant's syringe over here. We haven't really talked about this guy, but you'll notice that the air for the assistant syringe, all right, comes over here, tees in here, okay, to the exact same outlet, okay? And if that assistant syringe is instead teed in to that solid yellow or orange line, or if that syringe is teed into basically that regulated, that unregulated air coming back from the master on off switch, that is going to cause a problem as well. And that's actually probably a more likely culprit, is the assistant would be using their syringe to help the doctor when they're cutting teeth, and that decrease on pressure. But the whole point of what we're trying to get at is that if that syringe is causing this pressure to lower on this regulator, that is going to in turn affect everything. So hopefully this wasn't too confusing. I know when we look at these diagrams, they can be a little bit overwhelming, but I will tell you, it's diagrams like this that really help you understand how things work. And if you approach dental equipment with a method, with kind of a method in your mind where you understand how these hoses are all hooked to one another, this is what really makes the just the whole process of troubleshooting possible. And I'm looking at them right here, and I'll probably mention this again at some point, but I'm looking, and I also wanted to kind of call your attention, just as a little bit of a bonus here, to the white and the purple. Now you'll notice that here, all of these lines are all hooked to something, okay? But then you have the white and the purple here. On this particular type of unit, which is an Adec Century Plus or a Cascade style, you have extra lines that run through the arms. Now, the purpose of these extra lines is so that if you ever do have a problem where a line gets cut inside the arm and you can't access it, these lines are spares. And so if you imagine that, like from, say you had inside the umbilical, say this one right here was cut, this orange one. What you would do is you would essentially take that purple, hook that up in place of the orange, and then you would have a brand new line. And this is especially relevant here where you have you basically have an arm. This is a harder umbilical to get to. So like if you had a problem where, say, your this line right here, right, your solid yellow had a problem, then you would be able to go ahead and say take the white and sub out the white for the solid yellow. So hopefully this was helpful to you. If you have any questions about these concepts, please feel free to chime in below. I'm trying to teach these things as good as I can, thinking about how kind of how these repairs really go. But if there's ever anything you want to see, I definitely read all the comments and I'll reply back as soon as I can. So again, this is Jason from the Dental Equipment Repair Channel. Thanks for tuning in, and I hope this was of some value to you.